Hi, I'm Aaron McIntyre, Building Science Engineer for the Seed Home. Now that you understand what the thermal envelope is, we see how the structure separates a conditioned space from unconditioned space, the outdoors. Shape and configuration of the envelope are also important. Here are some fundamentals that affect how the envelope performs. Energy moves through a building in three ways. Listed in order of impact on the building, energy moves through convection, conduction, and radiation. Let me briefly describe each of these. Convection is the movement of energy through fluid. In our case, that would be air. A simple example is air that is heated inside the building that then proceeds to leak out of the building. This is typically the single biggest area of heat loss in existing and new buildings. Any place air moves into or out of the building will have a large effect on efficiency. This also holds true for exhaust fans, fireplace flues, etc. In designing and constructing the envelope, you want to pay very close attention to identify and minimize the convective pathways through the envelope. Conduction is the next to impact the building. Conduction is the movement of energy through a material and always moves warm to cold. When you hold a fireplace poker in a fireplace, eventually the handle you are holding will get hot. That is a result of the heat moving from the hot fire up the cool handle through conduction. The same impact happens throughout our buildings. Materials moving energy from warm to cold through the building envelope. To counter this, we need to understand that some materials are less conductive than others and to design the envelope with materials of lower conductance. We must also look to the use of certain materials and designs as thermal breaks in the envelope. Any area of the envelope that has a direct pathway from interior to exterior are candidates for the use of a thermal break. Some simple examples would be the concrete foundation or a wall stud within the walls. The two areas of the envelope that are often direct pathways for energy loss or gain in a building. As you move through the home today, you will see examples of how to eliminate these conductive pathways in the envelope. Lastly is radiation. Radiation is the transfer of energy through space from surface to surface. All energy on the planet Earth arrives in the form of radiation from the sun. Energy from the sun's surface travels through space without heating space until it reaches the Earth's surface. From there, the energy moves about the Earth and in our buildings through conduction, convection, and radiation. While radiation is important, in cold climates it typically has the least impact on energy gain or loss in our buildings. Radiant energy has the greatest impact in warm climates on cooling for the home, as the sun's energy through windows has a large impact in warming the interior surface, which in turn transfers through the home through convection, conduction, and again radiation, warming the entire home. We again will look at examples of radiation as you move through your tour today.